And we're just going to do a little demonstration of network forensics in action here. And what happens most commonly in breaches is, there's a user action that causes it. Today we're dealing with a situation where the majority of our breaches start with an inadvertent action on the behalf of somebody inside the network, or somebody visiting a malicious site or something like that. And then right behind that in the pecking order is web application attacks like SQL injection to web server and things like that. So the concept of hacking through infrastructure, hacking through Cisco IDSs and Juniper IDSs and IPSs and firewalls, that's not happening nearly as commonly as it used to, because we're getting much better at infrastructure security, but we're still having issues on the user side and on the web application side. And it's no accident that these are, the two, I guess you could say, emerging areas for us. So with network forensics, essentially what we do is we're looking for needles in haystacks. And one of the ways, and I quote this from Brett that works at a company I used to partner with, but we find needles in haystacks, and then we try to remove all the hay to find the needles. Once the needles are found, we put some hay back around them to try to get context to answer the questions of what, when, where, and how, and then put together the pieces. Essentially, we're in a situation where operating system and host-based forensics tools and host-based forensics techniques can lie to us. There's a whole art in the world of hacking called anti-forensics and anti-incident response. A lot of that's propagated by rootkits and things of that nature, but the whole point of it is to make forensics useless. Now, there's a lot of research, a lot of innovation, but packets typically always tell the truth. It's much harder to make a packet lie than it is to make an operating system lie. And we're going to do a demonstration to show you specifically how a specific rootkit is going to hide everything from your traditional forensic suites that you would investigate the live system with, and how the only way we're going to be able to piece this case together is through traffic. All right. So a timeline of events here, I just kind of want to give some context as to where OmniPeak and OmniAppliances and all of this stuff fits into the equation. So typically we know something happened because our FireEye, our Blue Coat, our Cisco infrastructure has alerted us to something. And really where OmniPeak shines as far as my workflow is right after that point. Because while these other solutions that we see at the top there, like the FireEyes and the Blue Coats, are great at saying, hey, something's happened, we need something else to say, okay, what happened specifically? Give us details of what happened. And usually that's what management wants to know, is what happened, how it happened, and what are we going to do to make sure it doesn't happen again, what was taken, those kinds of questions. So in that phase, I usually, use OmniPeak or something in OmniAppliances to kind of help me answer those questions quickly. And then there's a third phase where we do like a deep dive. So now we know where the malware is. We know which machine it's on. We've pulled it off that machine. And then we get into our reverse engineering, our malware reversing, our data analysis, and things like that. But to get from the very beginning where we know something's happened to the point that we're digging down into a piece of malware, OmniPeak has, at least from my workflow and my practice, sped that process up exponentially from getting to step 1 to step 3 in this timeline that you see here. And what I'm going to demonstrate to you is exactly how it's sped that process up. So the two demonstrations we'll be doing, one will be simply a rootkit that will be put on a system, and we'll see how it can covertly exfiltrate data. How traditional forensics are looking at the host traditionally doesn't really show us anything because that's the purpose of a rootkit, is to evade forensics. All right, and then second, we'll look at a web server being taken over by SQL injection. So I'll SQL inject it, upload a malicious file, and then use that file to take control of the system. And then we will immediately go and look at the forensics from the network side on both of these to show you how really the only answers lie in the packets because of the uses of rootkits and things. So let's go ahead and start with that. All right. And I'll just show you the rootkit first and how that kind of works. So essentially, with this rootkit, and this is a common, I like to use this rootkit as proof of concept. Part of it is just a responsibility thing because I know people are going to go get it and download it and try to play with it. And this is one that I'm purposely using that can be detected by most antivirus solutions. But I need to point out, and I want everybody to understand that of malware out there, that's a major piece of malware, has the capabilities to do what I'm going to show you with this rootkit times 10. So this is just one example. I don't want you to get caught up in this specific rootkit so much, but just understand the functionality and know that any malware that you get possibly has this capability. All right. So this thing is going to run netcat in the background, have it listen on a port here, in this case port 100. And it's also hiding the netcat executable from the operating system, from processes and the file table, so you won't be able to see it. And since it's listening on port 100, we're also going to hide the listening port as well, so that if we did netstat or tried to do local net forensics on the host, we wouldn't see that socket. So I'm just going to save this INI. This is how we interact with the rootkit, and then run the rootkit. And with this, we have the understanding that typically a hacker would have planted this on a website, had you visited, you downloaded a game or some type of file and ran it, or a PDF and opened it, and it launched this process as a result of that. So forensically, if we look at this machine locally, if I go to Task Manager, I don't see netcat running anywhere in the processes. And it doesn't matter what you get, because anything you install on top of the operating system simply reads information from the operating system, and we're fooling it at the kernel level, so that kind of takes away installing anything else. So when we run a netstat, and this is the important part to look at here, if you notice, it shows us that listening, there's something listening on 25, the mail server, something listening on 80, and then we jump to 110. Now, we know that there's a rootkit running here that's listening on 100, but what I want you to pay attention to here is we see that that does not show up in our netstat listening here. And even if we did an SC query or something like that, we still wouldn't be able to see that process anywhere in the services. So it's truly hidden from the kernel, and this evades most, just those two techniques evades most modern forensics. So now let's prove that the rootkit it really is running. If there's nothing listening on port 100, which netstat just told us there's nothing listening on port 100, then why is it we're able to basically telnet to that machine? And let's look at its IP address so you can see that. All right, it's 142. So if nothing's listening on 100, then how are we able to telnet to port 100 on that IP address and get a command shell? And furthermore, if you look at that, we're running with system privilege, which is the highest possible privilege in Windows. So at this point, you're kind of in trouble as far as, traditional forensics goes, because the rootkit has totally evaded itself. The threat actor has complete control of that system. He's interacting with it right now. And locally on that system, there's nothing you can do to really show you that this is going on without shutting down that rootkit first. All right, so we'll just make a directory, and we'll change that directory, and then we'll make a file on the desktop. And we'll just say owned. So we just entered a few commands, and that's just to give us some traffic, all right, to go examine. So now what I want to show you is how, we'll get called in, because this is a scenario that plays out over and over again. We'll get called into a situation like this, and a lot of the questions or a lot of the data that we ask for, the customer just might not have it, or they might not know where it is. So we can come in very quickly and start asking for packet captures or traffic captures. And one of the really cool things about the WildPackets suite is if you have like the Omni appliances, we can kind of do this in real time. Now, right now, we're looking at this case from a static historical standpoint, but we could do this in real time almost if we had Omni appliances standing up on this network. So I'm going to open the PCAP file that was generated from that attack that we just saw with the rootkit. and show you how we would go about investigating it. So when I start up or when I bring in a PCAP file, and this might be like a 5, 10, 15 gig PCAP file, the first thing I do is go to my dashboard view and start in Compass, because Compass gives me a very overviewistic type of view of what's going on with the traffic. And I can see really quickly here what the traffic patterns look like. I can see where there was in the amount of traffic or types of traffic being generated. And one of the really slick things is I can actually just highlight a section on the timeline here, like so. All right, and then drill in on that section, and then I could right-click and say, show me packets that are related to this, and copy those packets by themselves to a separate window, and that immediately gives me a whole nother tab up here at the top. This is where we started, but this gives me a whole nother tab that shows just the packets that are related to what I picked on that timeline. So just instantly there, if I know about when the attack started or when something malicious happened, I could very quickly just cut out a cross-section in history of the packets that happened at that time just by doing that little drag and drop that you just saw me do there. So looking at that, I can see that, there's some traffic between my victim, and in this case, my victim is 129 because the IP changed there. But I can see that there's definitely some traffic. See that there's something called own being created. So this looks like some command line activity. All right. Now, with that being said, right away, I can instantly go down to the peer map under the visuals and kind of see a map of traffic between the devices that we're communicating. And I can also go back to the very beginning where I can see all the packets and do a peer map of that and see the peer map for the entire session from that time frame. So one of my favorite views here when I'm investigating something like this is I like to go pretty quickly into flows after I've gotten my overview. And by the way, to get back to the overall view on the graph here, I can just double click and it takes me back and shows me the entire timeline. So I like to go into flows because for those of you that are familiar with things like Wireshark, when you select the packet and say follow TCP stream, well, OmniPeak actually creates every possible TCP stream in the background in real time for you. So when you open a packet capture, every stream's already been followed and it's stored in the flows view for you. So as I look at my flows here, I can see, all right, there's definitely some traffic between my victim 129 and 134, and it appears to be on some port named new account. Now, maybe I don't know what port that is or what that means, but I can see there's 19 packets that was transferred. So I'm going to go ahead and right-click that and say selected packets by client and server. I only want to see traffic between those IPs because now I'm not so much concerned about the timeline. I'm more concerned about traffic between those two. So again, you're going to see it opens up and creates an entirely new tab for me related to just those two IPs. So what we're getting at here is I'm constantly drilling down into what the problem may be. All right. So one thing that jumps out at me right away is now I can see clearly that the port in question was port 100. And I can also see that the first packet is a SYN, there's a SYN-ACK, and there's an ACK. And in the world of networking, that is known as a three-way handshake. So that tells me a connection just happened there over port 100. All right. And furthermore, I can go right into this panel on the bottom left here and look at the layer 4 or the transport layer and see that, yes, there is traffic going to port 100 on that machine. Now, if this attack was still ongoing, I might go back to that machine and say, well, let me go see what's listening on port 100. So I go back to the victim and say, all right, well, let's look at the services. Let's look at NetStat and see what's listening on 100. And all of a sudden I see, wait a minute, the machine says I don't have anything listening on 100, but the traffic to and from that machine tells me otherwise, that there is something listening on 100. So in this case, I automatically know that there's probably a rootkit or something, because when there's a conflict in what the packets tell me versus what the system itself tells me, I always trust the packets because systems are very easy to manipulate, as we just saw with this rootkit. And at that point, I could go into triage mode and drill down even further. I can say, tell the customer, all right, here's evidence item number 1. There's definitely a connection to port 100. Here's evidence item number 2. That connection spawned what appears to be a command shell. If we look over here all the way to the bottom right, because that's a standard Windows command shell banner. And then we can even go further to see, what commands were actually typed. We can see where the directory Keatron was being made and investigate the whole thing. And now we have a lot more to focus in on. We have some signatures. For example, I might tell some of my guys to go and scan the entire enterprise right now and see if you see anything listing on port 100. If you do, go investigate it and work with the IT and the CISO having legitimate applications that also listen on port 100. So just in a matter of a few minutes, I'm able to get to that point of making sound decisions, and those decisions are based 100% off factual information, not some magic Jedi intuition that a lot of us like to sell the security industry as being. It's all facts, and OmniPeak in this particular instance gave us the ability to drill down into those facts really quickly. Now, I want to point out another thing in Compass. So when we look at all the packets, if I go back to the beginning here, I can do a Control-E, and I can basically pick a timeline. So I can say, look, I only want to see packets for the last 5 minutes. So I can say from, 18 or 17:34 to 22:36. And then it gives me those packets again in its own view as we see it here. So I'm very flexible as to how I can chop the data up. And for those of you that have done real network forensics before, that's one of the challenges is you have so many packets, so much data. I mean, I've had people to mail me PCAP files on external storage that are, like 300 gigabytes, 300 gig captures, and it really becomes important to cut that down into something manageable really quickly. And I haven't seen a better way to do that other than using OmniPeak with some of the little features that I've just shown you here. All right. So we're going to close out of that case because I've got enough on that case to send my guys off to, they know what to actually investigate now. And I want to jump right in and show you the SQL injection one. All right. And this is simply a 2008 server running SQL 2008. And again, I don't want us to get too caught up in the exploits here. I use the exploits because that is one of my areas of expertise, just to show you how we can investigate them. So this server is sitting at the IP address of 149. So I'm going to browse to the SQL login page on that server from my Linux server here. And when we browse to it, what we get is this login field. All right. And the way it works is if we logged into this server with a proper username, we get access to that account, username and password. If we don't know the password or an account, we get access denied. That's the logic of how a web front end to a SQL database works. Well, what we're going to do is we're going to do a few injections here. So I'm going to, first of all, create a user on the server named WildPackets, all right? And this is just standard old vanilla SQL injection to a Windows operating system. I'm using the stored procedure of XP command shell to access the command line via SQL. So if we go check that server now, we can validate that there's no user that exists in Active Directory on the server named WildPackets. So not there. All right, that's all the Active Directory users. So we do our injection, and access denied is typically a good thing with SQL injection. Now we go back and check the victim server, and we refresh the Active Directory. We can see that now there is a user in Active Directory named WildPackets. So via SQL injection, we just LDAP injected a user into Active Directory on that account. So if we go and look at the The next step is privilege escalation. If we look at the domain administrators group, one of the more powerful groups in Active Directory, we can see that the only member is administrator. We'll change that. We'll make WildPackets a domain admin. So we go back, play the attacker again, and I'm just going to do a simple change here. Instead of net user, I'm going to do net group. And the group that I'm interacting with is domain admins. And I want to add the user WildPackets to the domain admins group. So we perform that injection. We go check Active Directory on that victim. We can see that in the domain admins group, WildPackets is now domain admin. So we went from just logging in to being able to inject in the LDAP and the Active Directory. We have a user account, and that account has admin privileges. So the last thing I want to show you with the SQL injection is I'm actually going to upload. I'm going to create a binary, all right, on my Linux machine here, named WildPackets. And what that binary does, and I'll just show you the command I entered to create it. So this is how I created that binary. This is simply using Metasploit's MSF payload. It's just a reverse shell. It listens on this IP, which is this machine's actual IP. It listens on this port, or calls back to this port. So if you run this on a Windows machine, this binary, that machine's going to send the command shell to this IP address over this port. So kind of, you know, a makeshift backdoor. And then after I created it, I stored it in my TFTP location here so that I could easily access it. And via SQL injection, I'm going to pull that up to that victim Windows machine. Now on this side, this is my Metasploit handler that's basically listening on that port so that when that shell comes over, it can actually grab that shell and handle it and give me command line access. So I'm going to make these a little smaller so we can see these things happen in tandem here. And I'm going to do the injection where I actually bring it up first. Don't need it that small. So that injection would simply look like the following. And we named it wild.exe. So I'm going to say, hey, grab that file. And, you know, access denied is good. Now, realistically, we don't really know. We're kind of going blind here because we don't know if the file got there or not. We could kind of check it just by doing a dir command in the current directory for wild.exe and then writing the results of that to somewhere we can browse to it. Because remember, we're pretending like we don't actually have access to the server. So if I do a directory to see if that file is there and write the results of this text file, then I should be able to browse that server because it is a web server that I've reconned. That's 149. And I can see that it does show up as being there. So I know that my injection of uploading that file worked. So now the only thing is left is for me to run that file, and it should give me, again, command line access. So I'm just going to say, hey, Windows, run this file, and I'll drag over our handler here so you can see what happens as a result of us submitting that. So I'm going to go ahead and submit the injection. And eventually we'll get a connection back. So what I want to show you, because we have captured that traffic as well in a PCAP file, is what that looks like. So again, the place I start with the traffic capture, because in this particular instance, the real world scenario of where this happened was a customer had some data to show up on Pastebin, which is a common hacker site or data exfiltration site where they post things that they've pilfered from places. And they told me for a fact, hey, we know for a fact this data only exists on 2 servers in the world. and it ended up on pastebin. So if somebody had to compromise one of these two servers and only one of them have an internet reaching or facing page, and it's just a login to be able to access some other benign data. So being able to know that information and get a packet capture of traffic to and from that machine, again, I go right to Compass and immediately I can see, where the spikes are in traffic. So I hone in on those two areas immediately, and I can start to kind of see, what's going on. So I'm going to select the first spike, select related packets, and copy those to a new window. And I can see there's a lot of traffic, to and from the internet. So, somebody could have been scanning it or whatever the case may be, but I'm just investigating at this point. All right. So I go back to my original Compass view of the overall data set, and I hone in on the second spike, and I want to select those packets, keeping in mind my original packet selection still showing up there as well. But in this second one, there's a little more data for me to kind of pay attention to, because I can see that there is some traffic between this machine itself and another internal machine, which is 177 in this case. So what that tells me then is I want to try to focus on just those two IPs. And in this case, I'm going to go a different route. I'll look at my peer map, and I can see that, and I can also, again, see, all right, this is one machine, this is 150 that's communicating. There's a 149 in the equation, and then there's 177 here as well. So what I'm going to do at this point, since this machine is 149, is look at traffic between 149 and 147. Quickest way to do that is flows. Now, what I want to point out is how, again, even though I went slightly a different route from Compass, I still started at Compass, and then I went right to peer map, and peer map in this case showed me which communication path I want to look at first. All right, and I go look at the flows, and I can clearly see there's quite a bit of communication between 177 and 149. So I want to go and do a related package to that, and I want to relate it by client and server, so just those two IPs. And again, it beautifully gives me yet another tab that shows me just specifically what I asked for. And right away, I can see, oh, there's a SQL, what looks like a login, because it says client, it says SQL. I can see some other SQL stuff there. But even if I didn't see that, I know that it's HTTP traffic, and it's a GET method. So I would look at it just for the sake of saying, okay, what were they getting in this HTTP traffic? So I can see that looks like to be a login. There's some graphics that appear to show up on the login page here. There's a favicon. So all of this looks normal. And then I can see the login page. Go down to the bottom right here and look at my details. And I can see, all right, it's a username and password it's asking for. And then there's a bad login that appears maybe they get redirected to if they enter the wrong username and password. And I'm just carving through these really quickly here until something looks interesting. And right now, nothing looks interesting to me. Right? So as I scroll down, all of a sudden, I see something that does look interesting, because in this little part that I've got selected, we can see that there's actually a SQL injection attempt accessing the stored procedure XP command shell, and it looks like they did a net user command and created a username WildPackets with this password, et cetera, et cetera, et cetera. So we can clearly see where that happened. And again, the key here is not the fact that we can see it, it's the fact that we can get to this point quickly, because there's obviously going to be a lot more in-depth investigation at the packet level and at the machine level, but OmniPeak has given me a way to get to that point much, much faster. I gave a statistic to somebody a few months ago where adding this into my workflow, I've been able to increase the time in some cases up to 80%. I can give them answers that I can get from that first point of something's happened to here's what probably happened 80% faster in some cases, or in a lot of cases actually. So that's two classic examples. I wanted to show two classic attacks. SQL injections is still a problem in a lot of places. And the rootkit thing, that's really, really big for a lot of people. Again, any next level malware that you see out there that you get or that you get compromised by is going to have the ability to do what this rootkit did. Yes, there's something definitely listening on port 100, but we can't tell that from the host. The only way we know that is by looking at traffic. And these kinds of things and these kinds of attacks are exactly why network forensics is so important to what we do day to day. I used to do a lot more pen testing than anything else. Now I would say my RFPs for 2013 and 14 have tripled the number of RFPs I've got for pen testing, because now a lot of that work, or a big part of that work, is doing intrusion investigation, breach investigations, and exfiltration investigations. And a lot of my clients have told me straight up that, hey, this seems like magic, and it's really not magic. It's just knowing the flow of things and having the right tools. And I can say for some time now that OmniPeak is definitely a key part or a pivot part of my suite of right tools.